Okay, hi everyone. I'm MLRun, and this is Bruce. We're going to talk today about GenAI applications, how to build production GenAI application using several tools, Databricks, MosiacML, and MLRun, which is an open source software from McKinsey, and Iguazio, purchased by McKinsey. We're the two speakers. I'll start. I'm MLRun. I'm co-founder of a company called Iguazio, purchased by McKinsey. Prior to that, being VP, CTO in different companies, including Mellanox, which got purchased by NVIDIA, author of an MLOps book for O'Reilly, and do a lot of sessions on productizing GenAI and AI applications and MLOps.
My name is Bruce Philp, tech fellow partner within McKinsey & Company, but part of the Quantum Black team. We were acquired by McKinsey. We're now the advanced or AI arm for McKinsey itself, really helping clients to be able to scale AI across their organization. Very nice to meet you all.
Before I hand it over to Bruce, he's going to deliver the first part, and then I'll do more demos and deeper dive technology. One of the challenges that we have in McKinsey and Quantum Black, because we have about 5,000 data scientists and data engineers working on projects, is building common components that we can productize solutions really quick. So what we'll show you is how we're been doing it. Some of the things that we're showing you, or most of them, are open source, and you can use them, leverage them as well.
Awesome. So, the last year we've seen across a lot of clients, how quickly they have been able to build a proof of concept, a prototype itself. And when it actually gets to moving that prototype into production itself, they're faced with a number of challenges. Everything from, IP leakage, thinking about, how do they really get the right quality of the data itself to be able to consume from these GenAI applications? Thinking about, how do we bring monitoring across the whole end-to-end ecosystem itself? How do we know what's happening? Where do we have challenges itself? And we see, as you start to move this journey of going from a prototype itself into production, you'll start off and you'll have a set of notebooks, you'll have some data uploaded to a vector store itself, you'll have a very simple Q&A application itself, and everyone's super excited, right? You present this to the C-suite, business leaders. And everyone's like, hey, how do we get this into production now? Let's actually get it out there. Let's start to actually use this. And we see that there's a lot of challenges to be able to go from that prototype itself into production. And invariably, you're spending a lot of time to actually refactor the code base itself. What we typically see is you think about productionized solution here is 3 different pipelines. You have your data pipeline itself, and we'll dive into this in more detail as we go through this. Your modeling pipeline, how do we ensure that as we're using an LLM or we're fine-tuning or training an LLM itself, how do we ensure that we have the right quality? It's behaving as expected. And then the application pipeline itself, end-to-end solution that's going to receive the request, make a call, and get a response back itself. And then the fourth part of this, or third part of this, is the monitoring, right? So all these pipelines are actually generating a telemetry itself. And we want to be able to collect this telemetry. We want to be able to see and observe what's happening across the end-to-end application. This allows us to really think through, where do we need to improve the quality, the accuracy itself? Maybe we have issues with risk. How do we improve those? How do we identify where they are? And we think about, this collection of this metadata that we're collecting, or the telemetry itself, and we start to use that to be able to look at the feedback into the application. How do we continue to improve the application itself from the telemetry that we're collecting? We break down the GenAI reference architecture into 4 different components, and you'll see this across many GenAI solutions themselves. And we have your data part of the journey. How do you take this data? How do you prepare it? How do you actually get it to the right quality itself to be consumed? Then you have your model pipeline. So thinking whether, depending on the type of problem that you're trying to solve, you may have to think about tuning, fine-tuning that model itself. Or if you're using a model off the shelf, it doesn't matter what approach you take. quality is such an important part of this journey. So how do you think about validating and testing, the inputs are behaving as expected from the model itself that you're using here, and then deploying this? And if something fails, how do you roll back through this process? The bottom part here is you think about the application pipeline itself. You have this request that's coming in from the end user. You need to enrich that. Going off to the vector store itself, thinking about similarity search to be able to find the information, enrich it, incorporate it with the prompts itself, hand it over to the LLM itself, make your prediction and get your response back, and really ensure that you're getting the right quality coming back from the LLM itself. And then the live ops, or you would say monitoring live ops, but that plays a critical role, collecting all this telemetry itself. We may use some form of labeling here to look at that data to be able to say, how can we use this to continue to improve the quality of the application? Risk is such a critical part of this journey, and I'm sure that you're all experienced in seeing those challenges as you work with GenAI itself. Now, on the top right corner here, we ask a question of the LLM itself. What is RLHF? And the LLM is very determined, comes back with the results. It's not what we expect, right? And so hallucination is a critical part of this challenge of how do we deal with the requests that we're making, the responses that we're getting back from the LLM? How do we validate that? You'll see at the bottom here, there are a couple of other examples of challenges of not having guardrails, right? We have a request here to join a terrorist organization. Early phases, we were able to actually get a response back, and there was no guardrails in place to be able to handle this. We're now seeing, the guardrails play such a critical part, and you'll see from Yaron as he presents part of the demo itself, how he's incorporating some of these guardrails as part of the fine-tuning and training of those LLMs. We talked a little bit about the different components of the architecture itself. We see a lot of clients facing a lot of challenges here in terms of how do I continue to think about risk across the journey itself, and really ensuring, as we're bringing in data itself, right? How do we ensure that we have the right quality? How do we ensure that we're handling some of the challenges with PII, handling anonymization, duplicated content that we want to filter out of this. And then, we'll see a little bit more on the modeling side, but, really ensuring that we're validating the accuracy here, and to really ensure that we have good responses coming back from the LLM itself. So taking the inputs, validating them, and ensuring the accuracy is back from the response. We've seen the importance of tests here as you think about, maybe switching to a different version of an LLM or another LLM itself. We've seen a lot of clients actually face a challenge that their pipelines are actually broken and the responses are broken from that. So having tests in place is such a critical part here. The application itself, there are a couple of control points that I think are important to call out, right? We have the user making a request. We may have some toxic information that's coming through in that request. We may have malicious or injection of harmful components that are coming into this application. So how do we handle that? And then, as we make the request itself to the LLM, the response that comes back, we need to ensure that we validate that response, right? Do we have the most recent information? How accurate is that information itself? And so, think about these guardrails as you think about the journey of building your GenAI solution. We'll jump into data management, and this is a critical part, and we see a lot of clients will take a set of documents, upload them to a vector store, and then realize, hey, we're not getting the responses and the quality or the accuracy of the responses back from the data that we've uploaded itself. And so a lot more attention, I can't explain how important the data engineering part of this journey is. But also the type of transformations that we're using here, right? As we think about structured data, we typically use filters, group bys, relatively easy to be able to transform the data itself. As we start to move to more textual-based information coming through this, we're starting to leverage transformations that are more oriented to NLP to be able to handle that information, to be able to really clean it, prepare it, index it, store it in the vector store itself. As part of this journey, with any pipeline, you need some orchestration. And on the left-hand side, we may use a variety of different types of technologies here to be able to orchestrate these pipelines. Airflow, again, Databricks, being able to run these pipelines and also to orchestrate these pipelines itself. I think what's a critical part here is that as we think about distilling that data pipeline down into a set of transformations, relatively straightforward set of transformations as you go through this. But a lot of clients actually struggle with this, really struggle with how do we prepare this data for consumption itself. So we start off on the left-hand side, with the raw corpus of documents, right? Documents, images, so forth, right? How do we extract this information? So PDFs, a lot of Python-based libraries out there to be able to extract the information. However, we start to see images that are embedded into PDFs. We need to think about OCR playing a role here. We've just started to do some initial testing with GPT-4o, and we're seeing actually some really promising results coming through from being able to take imagery, being able to take actual tables, charts, so forth, be able to pull this information out and to be able to summarize what we're seeing from those charts. And then, hey, we've got some information now. Now we need to do some filtering. And so your document may contain a set of character symbols that are not relevant. You may have some advertisements, you may have headers and footers that are not relevant for the content or how this content is going to actually be used itself. And so we need to pull that out and remove it. You'll see a lot of duplication across documents itself. And then also privacy, as you think about PII and how do you handle that? How do you anonymize it? How do you tokenize it to get it ready for being able to pass to the LLM itself or queried? And then we think about chunking this. And, I don't think there's one chunking approach that fits, every potential solution here. I'll say, as you think about your chunking size, if it's too small, or too large, too small, you'll have problems in terms of the responses that you're getting back from the LLM or what you pass to the LLM. You may not necessarily get the results that you're expecting. A couple of chunking methods that we've seen working pretty well across some of the work that we do, and we're thinking about financial reports, legal documents, manuals. Ragflow seems to be doing a pretty good job at giving us what we need from a chunking point of view. More specialized approach to chunking, we're seeing, for documents with latex, markup, and so forth, playing actually quite a critical role here. So we've got our chunks. We now tokenize this, and we create the vector embeddings themselves, and we store this information. I can't stress how important the data engineering part of this journey is, and not enough effort goes into actually really building this out and really thinking through some of the challenges that you need to handle. I'll give an example. Client had thousands and thousands of documents. And it was not clear at all what version of the document was the latest version of the document itself. And so as you think about this journey, think about the metadata that you're collecting across this, both from the files themselves, but also the contents. And so we found that extremely important as we think about collecting metadata, using that to further refine the content itself, further query, and get the right results that we're looking for. I think that concludes my section. I'm going to hand it over to Yaron.
Okay. Anyway, what I will do now, I'll go over several applications that we've built, 3 different applications. They're all based on the same component that we discussed here. The first one, which is relatively cool, it's a real-time co-pilot. So, one of the challenges around hallucination, if you just hand it over to a client, the responses may not conform with the policy and so on. So what people do is put a man in the middle. Essentially, I'm calling an agent. There is a co-pilot that we'll see here in a second, and it recommends to the agent what to tell the client. This way we have some sort of a proxy between the client and the agent. So what we've done is essentially we record both voices. We have real-time transcription. This is a challenge by itself, how to do it in less than a second to transcribe all the conversation. We pass this, we enrich the context with user data, historical transaction, policy of the company, etc. And we make real-time recommendations to the agent what to tell the client in real time. So this is an actual
Good afternoon. This is James Cook from Horizon Insurance. How may I assist you today?
Hi, James. It's Emily Johnson.
So this is a
I'm
real
calling to report the
conversation.
loss.
The
Unfortunately,
transcription
I
happens
lost
in
my
real
luggage during
time
my
as they
trip,
speak.
and
There
I'm
is a
not sure
transcription
what steps to take.
engine using an
I'm
open
sorry to
source
hear
model
that, Ms.
called
Johnson.
Whisper
I'm
with
here
some
to help.
acceleration.
Can you provide me with some details about where and when the loss occurred?
Sure. It happened in Lisbon, Portugal, at the airport.
I see. And do you recall the specific day of your trip when the luggage was lost?
It was on the second day of my trip, right after I landed at the airport in Lisbon.
Thanks for letting me know.
So after the model collected
Was
enough
your luggage
information, it
checked
starts
in with the
making
airline?
recommendation to the agent
Yes,
what
it
to
was.
say,
I dropped
what
it
are
off
the
at
critical
check-in counter
issues,
before my flight.
what's the budget,
Got it.
what are the constraints of the claim.
Now, let's discuss contents of your lost luggage. Can you provide a brief overview of what items were inside?
Certainly. I had some cash, clothes, jewelry, necessary hygiene products, and my essential medicines.
So you can
Okay,
actually
thank
see
you,
what's
Ms. Johnson.
covered in the policy and what's not covered in the policy while the guy is
Unfortunately,
talking to
according
the
to company
client.
policy, we don't insure any cash or jewelry stored in checked luggage.
So this
Oh, I
actually
see.
replaces an agent
I
that
had to
sees
read
5
my
screens
things, I
with different
guess.
information,
What
have to
about the
do
rest of the
searches,
items?
etc. This is all happening
Certainly.
in real time.
To assist you further, could you provide an approximate value of the rest of the items inside your lost luggage?
It's a bit difficult to give an exact figure, but I would estimate it to be around $1,000.
I appreciate that, Emily. I'll make a note of it and start the process for your claim, and we'll do our best to assist you in recovering the value of the lost items covered under your policy. I'll keep you informed about the progress and any additional information we may need.
Great, James. Do you know what the insured amount for lost luggage is by any chance?
Absolutely, Emily. I see here that your policy covers up to $20,000 per claim, so everything is going to be all right.
You can see that
Thanks,
the
James.
co-pilot
I
actually
really
came with the
appreciate your help
numbers,
during this
told him,
stressful
what's
situation.
covered, what's not
No
covered.
problem. We're
So,
here to support
think
you.
about someone
If you
just
have any
listening
further
on the
questions or
conversation, an
concerns,
expert
please
that
don't
gives you
hesitate to reach
advices all
out.
the time.
Take care, and we'll work on getting this resolved for you.
Now, it may sound trivial, but there are huge engineering challenges here to get to this real-time performance because it's actually transcribing in real time all the information. It goes to RAG, it collects data from 4 different data sources, transactional, documents, etc., responding in time. We actually didn't manage to do it with OpenAI and things like that. We had to use a smaller model based on open source. I think it was Mistral with fine-tuning. Also on the transcription, we had to use some special parallelism and acceleration for the Whisper model in order to really get to this level of performance. So sometimes people think, we're going API calling OpenAI and we're done. There are certain problems that you need to build something more specialized. The second application, still in the area of service operations, is what we call call center analytics. Think about a company, telco, or some big bank that has tons of calls from clients. We can do a lot of interesting things from those calls that we have, live calls. So we take all those calls, we transcribe those calls into text. The problem in the call, usually there's an agent and a client talking to each other, so we need to do something called diarization. It's breaking the call to sort of two people talking to each other, noise cleansing, all sorts of audio processing. And then we take the text and we start analyzing the conversation. The way we analyze the conversation is by having a bunch of prompts. A prompt saying, summarize the call, or a prompt says, was the issue resolved? Or a prompt saying, what was the sentiment of the agent or the client? So you can see a variety of applications that are manifested by just having prompts. There are issues around efficiency, how to make those prompts efficient. There are issues around hallucination. But you can see there will be many different applications on top of this text that we generated, things like summarization, assessment of the client, assessment of the agent, classification of the call. Was it about billing? Was it about products? What are the best products? What are the products people are angry about, etc. So we can grab a lot of data. And this is all done using LLMs. Now, when we started we also used, again, OpenAI and traditional tools. We ended up with huge cost per call analysis. It was just, we went back to the client, he says, no go. It's like, I need the mortgage just to analyze a few calls. So we started moving into open source LLMs. We started fine tuning. We added other tricks of, again, parallelism, micro batching. GPUs, they don't like small sentences, so we micro batch. So we increased the performance of the application about 60x. We reduced the cost to about 60x compared to the initial version by doing a lot of different engineering tricks. These are, by the way, the different screens. It's sort of McKinsey side. It's not without the client logos. But it can actually analyze throughout the conversation. It could tell you this is where the agent was okay. This is where the agent was sort of not working across the script. It should have said this instead of this. So it can assess the agents, assess the clients, can generate topics. Another interesting thing is if we want to train an agent, an automated textual agent, we can actually use this information as a fine-tuning for the chat, because we want the chat to behave like a real agent. So we can take all the good calls and use them for fine-tuning of the chat agent. So again, we made a significant breakthrough. We actually deployed this application in several banking clients. Again, very cost-effective and so on. The next application is more of a smart virtual assistant for an e-commerce application. I'll show here, but we've done it for a bunch of different clients. This is an example of a template of a sort of a chat application. Again, this is a specific one, so it may have different variations for different use cases. But we talked about those 4 pipelines. The first pipeline is generating the data. And as Bruce mentioned, you can't just throw a PDF and life is good. Usually you have to pre-process the document, cleanse it, structure it, and so on. Most people focus on vector databases, but in this application and many other applications, you'll have a hybrid of vector data, of key value data, of tabular data, etc. And so what you see here, we ingest data, for example, about user features. If we know information about every user, it's a male or a female, age, preferences, is a VIP or not VIP, etc., we can leverage that in order to provide better answers, more targeted answers to the client. So we have to have several tables that we essentially ingest data into. For example, user features, for every user, what's his characteristic. Structured data, maybe we have pricing tables for products. The client asks, what's the price of a table? So we need a structured data. And we have the embeddings. Within the application itself, there is a typical pipeline that we build. The first thing is the first transaction, you have to catch it, enrich with the user context. We want to know who's the user, authenticated. We need to enrich with the session, because the conversation has sort of a question, answer. So when we get the next request, we need to essentially get the entire conversation. Usually the next step after getting this information is something we call refinement. So essentially we take the history, we take the question, and we make it a better, more accurate question for the LLM to use. The next thing is, usually there are multiple applications, not one. Here we'll show one, but maybe he's asking about his bank balance, or maybe ask about documents around credit. So I need to build like a classifier or an orchestrator that tells me where to go. So that's the next step. And then we may have multiple chains, one for each application. And finally, we need to go validate, make sure there's no hallucination, monitor, track, store the results in some database for the next transaction, and so on. So this is the application pipeline that we'll see. All this information, this pipeline generates tons of telemetry, which goes to the monitoring system. This telemetry can actually be used for fine-tuning. So by adding some labeling, we can actually use it for fine-tuning. We have a sort of monthly webinar called MLOps Live, and we show different, there was also, last session I think was with Databricks, and we showed one example of how we use our LHF to keep improving the accuracy of a model. We actually exceeded the accuracy of GPT-4 using a very small model, but just keep on improving the accuracy of the small model. So these are just some some ideas. So how do we do the fine-tuning? In this application, we fine-tune a base model, an open source model, for two different purposes. The first thing, we want to make it more accurate and understand fashion questions. The second thing we want to do is actually put the guardrails in the model, because if we take the guardrail outside the models, it's more expensive, it's slower, etc. So we can actually fine-tune the model to tell it how to address different malicious or incorrect questions, and I'll show how we do it. In order to do that, we need to build a machine learning pipeline, get the data, prepare the data, run the fine-tuning, and eventually also do the evaluation, generate reports, so we know the model really passes the bar. So we use, in MLRun, there is something, you can build pipelines, and we now support also Databricks and MosiacML, so you can actually build steps in the pipeline, which will be go run some Spark jobs, run MosiacML fine-tuning, and then run maybe a container or a Kubernetes job for running the evaluation, all that in a single pipeline. Let me just show you another thing. This is, by the way, the fine-tuning data set that we used. So we essentially have a question, we have the correct response and the incorrect response. Sorry. So if the user gives me a question, how can I incorporate animal, whatever, then there is a correct answer, there is an incorrect answer. And so we want to make sure that it addresses the questions a much more appropriate way for a fashion store. I want to show you something at the end of that data set. These are essentially guardrails. So for example, if they ask something which is unrelated to fashion, instead of answering the answer, we're essentially asking it to provide a blocking answer. Sorry, I can't address that, or whatever. You can build your own answers. So this way, we didn't only tune the model to answer in the right way, more appropriate to a store in this case. We also tuned the model to block things that it's not supposed to answer on. And you could do, again, it's I think 1,000 rows here, but you can build a bigger data set. The next thing is building the application pipeline. So what we did, we leveraged, MLRun has sort of a serverless engine underneath that can compose DAGs or real-time pipelines. And what we did, we essentially did integration with LangChain, so we can actually put different steps in the DAG that are essentially LangChain components. So in order to build a full GenAI application, I need about 10 lines of code. So essentially, I build a DAG. The DAG has session loader, which is essentially getting a request, getting the user context in session. Refine query is this step that takes the session, takes the question, builds a better question. Retriever is sort of a RAG chain based on LangChain. I can tell it which data collection to go to, which vector database. And history saver is essentially the finalizer. So what I did is essentially said, I need a RAG application, 4 steps. I could deploy it as a fast API endpoint or as a serverless engine with a single command, and that's it. That essentially builds an entire application, 10 lines of code, containerized, telemetry, auto-scaling, all those things are built into the model. By the way, you don't see here an LLM. There's a YAML file where you can configure which LLM you use, et cetera, or pass it through the API. So before we talked about the guardrails, I'm not going to run everything live just for sake of, so we'll have some time for Q&A. But this is something I took from the app. These are 2 questions that I asked. Asking a complex question that involves general data and fashion data, and you see that it doesn't address the question. And when I keep on asking, you see that it explains itself. It's saying, I'm a shopping assistant, I can't address those kind of questions. And this is because I fine-tuned this into the model, which is pretty cool. So, but now let's move into the full example. So this is something we did for a fashion client, and since then we deployed it in other places. But this is, I think of it as a website. You're asking for a shirt, you're asking for jewels, for whatever you want. And it also has visuals, so it has associative search for images as well. you see that I can ask for similar clothes. It's actually doing vector search on the images. So here I ask for a white shirt, or I asked for a shirt, I got a gray shirt. Then I asked for a white shirt, so it got me a white shirt and pricing and all the different options. Now I'm looking for shoes to match my shirts. So again, it's using vector database and also tabular or key value database. So it has also features around what's suitable for a wedding, what's suitable for jogging, etc. So you see, it gives me shoe options, again, everything with pricing, because it combines data from a tabular database and data from the vector database and from an image database. You see, I can ask for sneakers, something more sporty, and it will get me other options as well. So this is a real live application we built for some clients. And again, you've seen we actually built this. The client engagement team told us, this client really needs a demo tomorrow. So tomorrow it's too soon, but we'll do it in 4 days. It took us 4 days to build this application. So this is, again, an example. One of the things that we're also going to open source is all this visual JavaScripting, React engine, so you can actually build things really rapidly with this UI that you see here. So just to summarize, what we've seen is how we address all this life cycle of taking the data, doing fine-tuning. We do a lot of things around performance to really make sure that we can reduce the cost and increase the performance. We do a lot of things around telemetry and monitoring. I didn't manage to show it here. You could see some of the dashboards here for Grafana and other tools, because the telemetry is built into all the microservices. So this way we can track all the hallucinations and quality and performance and resource uses and so on. MLRun is this library that allows this automation on one end and monitoring on the other end. So you could have all those aspects of taking code, building microservices and pipelines and so on out of it. It can also orchestrate Databricks for either Spark or MosiacML tasks. We have a bunch of ready-made components. So what you've seen, I actually built a pipeline in 10 lines of code because all the different components were already there. Or if you need to do evaluation or PII removal or fine-tuning, et cetera, you just place a component that you can see here from the marketplace in this pipeline. It also has a lot of aspects of efficiency, again, optimizing the GPUs, the auto-scaling, the resource uses, and et cetera, which reduces the cost. And it's a very open architecture. So if you happen to have something that has Databricks on one end and Kubernetes on another end and something else, we're now working with NVIDIA. If you've heard about their NIMs, we can now orchestrate NIMs. We're going to release it soon. So again, you could do all those different things without doing a lot of engineering to move to production. A lot of the automation for moving from this prototyping phase to production happens through automation underneath the hood. So I think that's it. So good. Any questions? And maybe Bruce, you can join me.
Maybe one of the things we didn't talk about is, how does an organization truly scale GenAI across their organization itself? And we see the importance of building blocks, and how do we embed these technical risk controls, the ability to expose the telemetry itself, and to be able to use this. And you talked a little bit about these building blocks, but such a critical part of this is those building blocks and the ability to bring them together to really, really build these GenAI solutions and be able to reuse these components as you move forward.
Good. So, I'm not going to dive too much into it, but one of the things that when we go to clients is we don't want them to do one-off solutions. A lot of times we help them build the framework, the overall platform, and the practices, and then build the use cases. So.